morning everyone. Welcome back to the session on fundamentals of computers. We were discussing about operating systems in the last class. I'll just give you a gist about what all we discussed in the previous class. We discussed about the definition and the need for operating system, and then the main functions of an operating system and the commonly used mechanisms inside an operating system. Now we know what do you mean by an operating system, its need, why do we require an operating system, and then we also know what are the main functions that an operating system does. Now after that we have to see what kind of mechanisms it uses to perform these functions of an operating system. We discussed about the process management in the last class. We were discussing about the logical architecture of the computer system, and then we started with the process management. Okay, and also we saw the process management mechanisms in early systems. We discussed how they used to manually load the operations one after the other into the computer system, and then with the help of a computer operator, a human used to do these actions manually. And then batch processing mechanism, they used to club similar kind of tasks into one batch and they used to process them. And then we have the job control language, JCL. These statements were used to facilitate job loading and unloading. They used to control what jobs need to be processed and at what pace or in what order they need to be processed. We also saw the diagram for use of job control statements in batch processing. These job control statements, they helped us to identify these similar jobs, and they helped us to complete the jobs that are there in a batch one after the other. Okay, and then we stopped here where we have to discuss the different types of programming mechanisms that we have in order to process those tasks. Initially, the first mechanism, if you see the generations of computers or before that, or in the first generation of computers, we were only discussing about the manual loading mechanisms, and then we had batch processing mechanism. After batch processing mechanism, what was the mechanism that we followed? Because manual loading mechanisms, we know this is the first generation of computers, and then we had the batch processing mechanism in the next generations of computers, where then we had the third generation of computers which had the ICs. The ICs helped us to program assembly language that are short codes that are sent to the computer, so that the computer would decode them and understand what instruction it has to follow. Also, we started with the machine language with zeros and ones, where the computer would understand them. And then at that point, when we were able to send instructions to the computer and the programs were being executed by the computer, at that point we came up with a concept called uniprogramming. Initially we had manual loading of tasks, then we had the batch processing. After that we had something called uniprogramming. We will see what uniprogramming is. Uniprogramming is like only one job is processed at a time, and all the resources are available exclusively for the job until its completion. In the last class I was telling you about the different applications that we open, and based on the applications and its requirements, how much time is it taking. We were talking about the idle time of a CPU, and we discussed what are the disadvantages that we have when we have the CPU in an idle state for a long time, or even after each task, if we had the CPU idle for even a few seconds, that would be of very much, that would cost us too much. So in order to reduce all those issues that we had, and also to maintain the processing speed and the efficiency of the processor, and to reduce the idle time of the CPU, we came up with different programming mechanisms. All these programming mechanisms like uniprogramming, multiprogramming, and then we will see multiprocessing, multitasking, multithreading, they are various programming concepts that are helping us only exclusively for the CPU to reduce the idle time. Okay, and you also know the main part for any CPU to perform and to determine its efficiency is the number of processes that it can complete in a required time. Okay, in a certain time, how many processes a CPU able to perform. If the CPU is only sticking with one task until it completes the task and it's not letting the other processes to enter into, then with the within a certain time the CPU will only be able to perform that single task. There are some tasks or processes that might complete very quickly and they do not require any other input or output resources, whereas some tasks they take so much time, and some tasks they might take minimum time, like or minimal amount of time. So it all depends. Suppose if a process is requiring an user input, and without that user input that process cannot move forward, it's in between, it's inside the CPU now, that process P1, and that process P1 is requiring a user input. Only it gets the user input, it will be able to complete the remaining part of its task. At that point, if the user is not looking at the computer, or if he doesn't give any input to the computer, in that case the process won't be able to complete its task, and it won't let the other processes also to enter and do its work. At that point the CPU is idle. And one more example I can give you is, that was for the input operations, right, for the user input. We can also consider for output operation. Now P1 process is having some task, that task is entered into the CPU, and at one point of time in the process it had to print something as an output. So how does it print? We have printers in today's world. You can just imagine that the computer is connected to a printer, and only once the printout is done it can complete the remaining process. Suppose at that point the printer is not turned on, or the process P1 is not able to access the printer, then in such a case, until the printer is accessed by that CPU, it won't be able to complete the task. So this is one kind of an example. So in any example that you take, the most common thing is the process, it's entering into the CPU, it's going somewhere else to the input output, or to the hard disk, to the secondary storage unit, to get some data or to do some work related to the process inside the CPU. At that point what is happening? This process is getting stuck somewhere with that work that is related to the task itself. But at that point the CPU is being always idle, and this the other processes that are waiting, they are not able to get the task done. So after seeing all these things, after so much development until the uniprogramming itself was very famous, or we had so many radical technologies that evolved until we had uniprogramming. In those days uniprogramming was a very good technology, or it was a very much good invention in those days. But after we started using uniprogramming, we had issues like what we are discussing now, like the printer issue or the user input issue or any other issue that is happening with the process internally. Any technology or anything that you take, it always keeps evolving. The reason is, until then we might not have access to that technology, we are creating a new technology. In that new technology, what we are doing, we are trying to use it. When we are trying to use the technology, we are finding some flaws in that, and then we are trying to upgrade ourselves, and we are trying to find out somewhat better than the technology that we had before. The same way, we had initially, we didn't have anything, we only had those punch cards type of input for the programs, and we used to manually operate them with vacuum tubes and all. Then at that time, that was a very good invention, and that was a very great invention. After that, when we started using it, we had so many heat issues and so many efficiency accuracy issues. Then we started to move towards the transistors, and then to the ICs. When we moved towards these transistors and all, we were using manual loading mechanisms. When we moved towards the ICs, we came up with these batch processing mechanisms. When we started using these batch processing mechanisms, we felt that instead of combining these similar tasks into batches and all, why not we try, or why not we find something which is automating itself. The CPU should itself take care of all these tasks, and it should manage all the tasks. At that point, we came up with a concept called uniprogramming. Uniprogramming was very good in those days, but when we started using those technologies, they had so many they had some issues, or they felt some faults in that programming concept. Then what we did, this is uniprogramming, the examples that we discussed now. Then after using uniprogramming, when we found some issues or faults inside that uniprogramming, we switched to multiprogramming. What do you mean by multiprogramming? Interleaved execution of two or more different and independent programs by a computer. Now in multiprogramming, what is happening? It is executing two or more different and independent programs by the computer. And the difference between uniprogramming and multiprogramming is, in uniprogramming, we could only perform one kind of a program, or the computer was only programmed to perform only a certain program. That is, suppose if you want to perform some calculations, if you wanted to use that system as a calculator, then it could only perform addition, subtraction, multiplication, division, or whatever mathematical functions that were programmed to that computer. Other than that, if you wanted that program to open a Microsoft Word, or if you wanted to read a PDF by clicking on it, or if you wanted to open a browser, this uniprogramming was not able to achieve the task. The reason is, the operating system or the computer was only given input for that single program, or only one kind of a task that can be executed. So what was happening? If you want to perform some calculations, mathematical calculations, that was possible in uniprogramming for that kind of a configuration. But if you wanted to open a PDF or wanted to search on the browser, we were not able to perform such tasks, because the computer doesn't know what to do and how to perform those tasks, as we did not give it any input. Okay. So they came up with an idea of why not the computer can handle multiple programs, because in uniprogramming, if we wanted to have three or four applications, or more than one application to be run by the computer, we have to create 2-3 systems. If we wanted to open a Word file, if you wanted to open a PDF and a browser, these 3 tasks are 3 different programs. So these 3 different programs cannot be done or cannot be understood by the uniprogramming computer. We need to have 3 different computers in order to perform these uniprogramming concepts, or this kind of a computer. Okay. So that's why we came up with a concept called multiprogramming. Initially, we were only able to process or complete one program at a time. Then we started to move towards multiprogramming. In multiprogramming, what they did, they were able to program, or they were able to give the input to the computer for multiple programs. The same way where we were talking about Word file, PDF file, a browser file, 3 different files, right, or 3 different programs. The 3 different programs does not need 3 different computers as of now, as of multiprogramming, because only one computer was able to understand multiple and different programs, and these programs were executed by the CPU whenever required and whatever task the user assigns. Okay. So you understood what multiprogramming is, what uniprogramming is. Now we will try to see the different types of multiprogramming we have. We have 2 types of multiprogramming. The first one is multiprogramming with fixed tasks. Fixed number of jobs can be processed concurrently. Okay. And the second one is multiprogramming with variable tasks. Number of jobs can vary. We will first try to understand the first type of multiprogramming. What does the first type of multiprogramming tell you? Multiprogramming with fixed task, MFT. It means only a fixed number of tasks can be processed concurrently. When you see this term concurrently here, you will easily understand what is multiprogramming with fixed tasks, because it is telling you that fixed number of tasks can be processed. Until there you understood everything, but the main thing over here that you have to understand is concurrently. What do you mean by concurrently? Concurrently means 2 or more tasks that are happening at the same time. Now just try to understand concurrently means 2 or more tasks that are happening at the same time. When you see the term concurrently, you should link yourself to the 5 generations of computers that we discussed before, and in those 5 generations there was one parameter that I was stressing upon, that is the speed of execution of tasks, the speed of the processor. Initially we had microprocessor, okay, the processes were able to complete in microseconds. The time taken to complete the processes we saw. For the first generation it was micro, and then we had nano, we had pico. Like that we have different kinds of speeds for the processor. Now if you consider micro, or if you consider the nano speed, what do you mean by nano? Nano means 10 power minus 9. 10 power minus 9, that means 0 point, and you have 8 zeros and a 9. The processors in the third generation used nano time, okay. The time taken to process one task was in nanoseconds, that means 0.00 and 8 zeros and a 9 over there, 0.00000009. That was the time taken to complete one process in the third generation. And when you come to the fourth generation or fifth generation, you had it in picoseconds, that means 10 power minus 12. What do you mean by picoseconds? 10 power minus 12, right? So 0.11 zeros and a 1, that means it is even taking even lesser time. Just imagine how much time how much time would it take for you to understand that 1 second concept or 2 seconds. You are able to see the time, or you are able to catch that 1 second when it is running, right? But when you want to understand, when you click on a stopwatch and you try to see the milliseconds that are there inside the that are displayed by the stopwatch, will you be able to see the digits when it is running? If you keenly observe and slowly observe, you might be able to find out some digits that are running in the milliseconds. Now milli means 10 power minus 3, right? That was used in the first generation of computers, and then in the second generation of computers we went to 10 power we went to microseconds. Microseconds means 10 power minus 6. We are not only able to see the digits in milliseconds itself in a stopwatch. Just imagine if will you be able to capture, or will you be able to see that microsecond time? It is very difficult. But just let's suppose if we have some practice, or if we are just trying to focus on that, maybe it is possible that you might understand, you might be able to capture that microsecond. But if it is in nanoseconds, that is 10 power minus 9, or if it is in picoseconds, 10 power minus 12, the human brain or the human eyes, your eyes wouldn't be able to capture those seconds or those microseconds or nanoseconds. The reason is it's very quick and it's a fraction of a second, right? So why am I telling you all this is, let's assume the first three types of generation, let's consider the first three types of generations, and let's see one task in 3 generations, okay? In the same task is assigned to the 3 different generation computers, the first generation vacuum tube computers, the second generation transistor computers, the third generation integrated circuit computers. We have all the 3 computers side by side, and we are assigning the same task to all the 3 computers. Now if you see the processing time of the CPU for these 3 computers, you will understand one thing. The first computer is taking double the time taken by the second computer. The second computer is taking almost 3/4 the time taken by the second computer. So if the third computer, that is in nanoseconds, that is 10 power minus 9, the second computer is in 10 power minus 6, and the first computer is in 10 power minus 3. The processing time of these 3 computers are like this: the first computer in 10 power minus 3, the second computer in 10 power minus 6, the third computer in 10 power minus 9. Now if the third processor or the third computer is able to complete that task that is commonly assigned to these 3 in 0.33 seconds, the second computer that is having a speed of microseconds, that is 10 power minus 6, it will be able to complete it a little slower than the third generation computer. and the first generation computer is able to complete, or it will take double the time that is taken by the second generation computer. So, if you see these generations, the first generation is 10 power minus 3, right? You will be able to see the time taken, or you will be able to see the processing time for the first generation computer, because it is 10 power minus 3, and we will be able to understand the time taken by the processor. The second generation 10 power minus 6 is it's difficult, and it's 10 power minus 9, that is almost equivalent to 0, right? 10 power minus 9, it's almost equivalent to 0, the time taken by the processor. Now if you understood the times and how much time each task is each computer is taking to perform the same task. Now let's take one more example. In this example, we have 3 computers. Okay, all the 3 computers are third generation. Now the first computer is taking 10 power minus 9. What is the speed? What are the speeds in the third generation computers? We have 10 power minus 9, that is nanoseconds. The first generation the first computer now we have is a nano speed computer, that is 10 power minus 9 seconds it takes to process the task. The second one is also the same configuration, 10 power minus 9 nanoseconds. The third computer, it's also taking the same time, or it's also having the same configuration, 10 power minus 9 nanoseconds. Okay. Now all the 3 have the same configuration, same processor, same generation, everything. Now I try to give the same task again. I am trying to give the same task T1 to all the 3 computers. Now I am giving task at a time. At a time I am trying to produce, or I am trying to input the task T1 to 3 computers, computer 1, computer 2, computer 3. All of them are having the speed of nanoseconds, that is 10 power minus 9. Now when I just click enter and give the task to the computer, to all the 3 computers, all the 3 complete at the same time. We know that because all the 3 are having the same speed, right? Now does it mean now all the 3 are able to do in the same time, that is 10 power minus 9 seconds itself, all the 3 computers are able to do the same task. With this you will understand what is concurrency means. Concurrency or concurrently, both are same. We have some concurrency algorithms that help us to achieve this concurrency mechanism. Okay, we will see, maybe I will try to discuss in some other concept, but it is a little bit detailed and a complex topic. So just understand, when 3 computers are performing that same task in the same time, then it is concurrency. This example is very important, and that's why I am taking so much time for this, because when we move to multiprocessing or multitasking, you should understand the concurrency meaning and how is it changing in those concepts, and what is it that varying. Okay. Now we know that we have taken some examples and we are familiar with the speed or the time taken for processing tasks in computers based on its processing speed. Okay. Now we had 3 computers, all of the 3 are in nanoseconds. Okay, nanoseconds, and all the 3 computers are given the same task, and they are all able to complete in the same time in the first 10 power minus 9 seconds itself. Until here we are clear. Just remember this concurrency concept, concurrently or concurrency concept separately. We will discuss about that concurrency concept in the next slide, where we will be discussing about multiprocessing. Okay. So fixed number of jobs can be processed concurrently. That is what programming with fixed tasks mean. Okay. And then what does that mean? They are able to perform multiple programs at a time or at the same amount of time, but in reality when you see, that is not the case. It just looks like the processes are being completed at the same time, but because of this very high speed that these processors have, it just looks like to us that all of them are being completed at the same time. But when you understand these speed concepts, they are being processed at very faster pace that we are able to only understand 1 second or in microseconds, right? We are only able to understand seconds and milliseconds. We are able to see them, or we are able to capture them through our eyes. but when we have it in nanoseconds, in 1 millisecond, that is 10 power minus 3, 3 tasks are being happening. So it just looks to us that all the 3 tasks are happening at the same time, but it is taking 10 power minus 9 seconds for each task. That way they just they are just viewed, or they are just understandable to the human, that they are being able to complete at the same time. We will go to the practical example that will be much more understandable for you. When you are opening 2 or 3 applications, the same thing, Word file, PDF file and your browser, and you are able to, and you are also able to open music. The music is being played continuously in the background, and you are able to work on your PDFs, or you are able to create some documents. When you see that kind of a scenario, you are able to understand, or you think that all of them are happening at the same time, all of them are concurrently happening at the same time. There are multiple programs, and these multiple programs are happening at the same time. But in reality, if you see in the internal working of the computer, each of it is taking around 10 power minus 12 to 10 power minus 15 seconds for a process to complete. When this is happening, we are in 10 power minus 15 means 10 power minus 15 means 0.14 zeros and 1. In that very short amount of time, a task is being done. So it is not in a just blink of an eye, you are able to process many tasks inside the computer. So when you are just able to process so many tasks at a time, we feel that the computer is handling so many tasks at the same time, but it is not the case, because for 1 second we are able to do hundreds of tasks, or we are able to tens of tasks inside the processor. We are able to do tens of tasks inside the processor. It's just assuming to us, or we assume it like the processor is being able to do all the tasks at the same time concurrently. That is the reason people generally say, or you see in books or on the internet, that there are multiple programs that are being done concurrently. But in the real life, if you see inside the computer, each task, or in 1 second the computer is able to do around 10 tasks. So when you are just trying to compare that 1 second with those tasks, it just assumes, we people just assume that the computer is able to do all the tasks concurrently. If you understood this much with the examples, we will move on to the next thing, because understanding concurrency or concurrently, this concept is very important, and you should try to understand as much as you can. Okay? And now multiprogramming with fixed tasks means there are multiple programs that, like the same way we were talking about PDF, Word and all, and the processor, multiprogramming processor, it's able to do all of them almost at the same time. Just understand that they are all happening almost at the same time, but not simultaneously or at the same time. Okay. Next, multiprogramming with variable tasks, MVT. Number of jobs can vary. This is, with the first one, the processor is able to only handle 3 or 4, that is by default assigned to the processor. But in the second one, the processor can handle any number of tasks, or it varies, depends upon the architecture of the multiprogramming CPU. Okay. Next, the area occupied by each job residing simultaneously in the main memory is known as main memory partition. We were talking about main memory in the last class, where we were discussing about RAM. The RAM first takes in, we were discussing that block diagram. Do you remember? We had a secondary unit here, input, output and then CPU. From the main memory, it was sending each and every task. First of all, whatever tasks that need to be assigned, they are residing, or they are staying in the main memory in partitions, and each of them are sent to the CPU for its operations. Once one process is done, it will go out, and then the control unit, which is in between the main memory and the CPU, it is controlling, and it is allowing the processes to come in from the RAM or the main memory. So we had so many tasks, right? Initially, when we had only uniprogramming, the main memory was like this, and whatever tasks that need to be done, it was sent to the main memory, and from the main memory it was sent to the CPU for its operation. We had no issues with uniprogramming. Then we started with multiprogramming. In multiprogramming, what happened? We are able to, the computer is able to understand multiple programs at a time. When the computer is able to work on multiple programs at a time or simultaneously, the RAM needs to be divided, or there should be some space for each task to reside in the main memory. If the RAM is not providing some space for the other programs, then how will the control unit or the CPU understand that there is one more process that needs to be entered? So that is the reason the RAM is made into different partitions, and based on the processes that are coming or programs that need to be processed, the RAM creates its partitions. That is what this means. Area means the size of the RAM that is there, that is occupied by each job residing simultaneously in the main memory, is known as memory partition. Okay, memory partition is nothing but in the main memory it creates partitions for each process, and how many processes are coming in, it will allocate some area for that process, and they all work simultaneously based on the processor that it has. Next, we will try to understand what is a job. What do you mean by job? We were already discussing about task, processes, jobs. All of them are quite similar and you can use them interchangeably. Now, we will see what do you mean by CPU bound. Mostly perform computations with little input output operations. Scientific and engineering computations usually fall in this category. Now, we have different kinds of jobs or tasks you can call, that is CPU bound and input output bound. We just saw what do you mean by CPU bound. Now, we will see what is input output bound. Input output bound is nothing but mostly perform input output operations with little computation. Commercial data processing applications usually fall in this category. Now, just try to link up all the topics that you are learning from the starting in this unit. Only then you will be able to revise all those topics, and you will be able to find a link between all the steps or all the stages that happened until now in this evolution journey, and you will be able to have a very much practical understanding of these concepts. Now, if you just when you try to read this CPU bound, when I read this CPU bound thing, I directly or I immediately had the thought of the generations again. The reason is, what does CPU bound mean? Mostly perform computations with little input output operations. First, we will see this line. Mostly perform computations with little input output operations. What does it mean? That means there are very little or very few input or outputs that are happening with the computer system. Whatever is the input that is given to the CPU, it is working on that continuously, and very few inputs or outputs are being happening. Most of the time is happening for the processor, for the processes to complete inside the processor. Okay, that is meant by very few or little input output operations. Then what is it that the computer is doing when we don't have more input output operations? Then what is that CPU doing or what is it working on with? There comes the second line, that is scientific and engineering computations usually fall into this category. What do you mean by that? When you see the military, when you see this military domain, or if you go into the research domains, they have different kinds of computers or very powerful computers that are more focused on processing rather than input output operations that we have in the normal computers or in the commercial computers. The reason is, all the data is sent into the computer or into the supercomputer or that powerful big machine at once, and the computer takes a lot of time to understand that data, to generate some insights from that and process the data accordingly. One good example for the CPU bound operations are, if you consider the census of India, or if you just consider the census of the world population, the data is very much huge and you cannot just imagine how much data it is. In such scenarios, you need not give the input every time to the computer, or you need not get an output every time from the computer. You will program the computer. These CPU bound computers are very powerful, and it is not like an ordinary computer. They have so much, they have very high specifications, and they are able to perform very high tasks, powerful tasks efficiently. So, we will see what those computers are in the later stages, where I will discuss with you about the types of computers. We have microcomputers, mini computers, supercomputers and all. We have mainframes, we have servers, there are different kinds of computers. We will see about all of these, but just try to understand that CPU bound computers are very powerful computers which have very high specifications, and with that, with the help of those specifications, the CPU is very powerful and it is able to perform, or it is able to process large amount of data at once. Okay. Now, when we are considering this census population data, you need not enter that data, or you won't enter the data one by one every time into this powerful machine to process the data. What we do, we collect all the census data or the census population of India, and we give that whole that huge data file as an input once to the computer. When you give that data file to the computer, what is happening? The CPU is taking so much time just to process it, and these computers are specifically designed for them. We just dump in so much data into the computer as an input to the CPU, and it takes some time, or takes so much time to process that data, and it gives an output, or finally whatever are the insights that are required. The same way these computers are used for many scientific and engineering applications, where they just always try to give data at once. They feed data into the computer once, and the processor takes its time to process all that huge data, and it gives us the insights. When we are talking about the census population, we are just providing the data to the computer and we are leaving it. The computer itself, it analyzes that data, it extracts what are the important things that are there. If there are some errors or some missing data inside that inside the census population, it tries to adjust them, and it will do whatever task that is assigned to that particular program. That way, after making all the computations, it just gives us an output. So, whatever is that is happening here, it is mostly focused on the CPU operations, or the time taken for the process to complete. So, that is why we call such processes or jobs as CPU bound, and these are still used in scientific and engineering computations in these days. In the early days, they had only those uni-programming concepts, or they had to only once give the input, and they used to perform the calculations based on that in those days also for the scientific and engineering computations. Whatever it is, in any period of time, they are given a certain set of data, and that is processed, that huge data is processed, it takes some time and it gives insights. Okay. And the second kind of jobs or processes that are input output bound, mostly perform input output operations with little computation. Commercial data processing applications usually fall in this category. Also, input output bound processors, you can just consider your personal computers or laptops also, because you always try to give some input to the computer. You try to find search for something on your web or the internet, and you just try to open some documents, you try to click on some applications and try to use them. All these things are happening with the help of your input. What are the input devices? We have keyboard, mouse, joystick, whatever it is. Based on the input that you give, there is a little computation when it is compared to the CPU bound operations. CPU bound operations, it handle huge data, so much data at a time. But these input output bound computers, you just click on a button or an application, you open a Word document, and it is a very simple task for the computer because it is very powerful. When you compare the power of the computer with that single task, it is very easy for it to complete it, and it is also based on the input that you give. Always you have to give them inputs, and you get output on the monitor or the screen that you have for that computer. So, here the computations are very less that are being happened by the processor, whereas the input and output operations are more. Input in the sense, we always type in something on the keyboard or we click something on the mouse, and the output is something that we see as on the monitor or as a display on the screen, or something in the in printout form. Whatever it all comes under your input output bound operations. So, you now understood very well about CPU bound and input bound. Okay. Next, we were discussing about uni-programming system, right? I will show you this block diagram in the next class. but try to understand CPU bound, input output bound, then what is the difference between uniprogramming, multiprogramming, the different types of multiprogramming with fixed tasks and with variable tasks, and what do you mean by concurrency, or what is that, what do you mean by that concurrently different applications being processed. So, this is what we discussed today. In the next class, we will discuss this uniprogramming system concept and we will move on to multiprocessing and multitasking concepts. So, that is all for today's class. Thank you.